ISA server optimization and integration with Windows 2003. In this nugget, we're going to take a look at some of the ways we can make ISA server work that much better for you. The first thing we're going to look at is the general optimization rules and techniques. These are just strategies that you can apply across the board to ISA server, to Windows 2000, to Windows 2003, things to keep in mind before you start optimizing your network. Now, after that, we're going to take a look at Performance Monitor in all its glory. Performance Monitor is a key factor when we start looking at monitoring the ISA server performance and optimizing it, tweaking it out, ensuring that it works in the best possible way. I'll show you some of the tips and tricks that I've learned over the years working with the Performance Monitor to ensure that we adjust the best possible parameters on there. I'll also look at some of the additions that ISA server has plugged into the Performance Monitor. Next, I'll show you the down and gritty registry settings that you can get into to tune ISA server to receive more connections, to optimize your port efficiency, and so on. Finally, we'll take a look at how to make ISA server work with Windows 2003. Because I'll tell you what, if you install it without taking a look at this, you'll find services failing left and right. So I'll show you what to do to make ISA server happen with Windows 2003. Before we get into how we can optimize the ISA server, let's take a look at putting things in context. First of all, you're never going to be able to optimize outside of your paradigm. And this paradigm list on the screen is things that you might want to change. First off, the server hardware. As my memory serves me correct, in The Princess Bride, Billy Crystal said, "You can be mostly dead or all dead." Sometimes the server hardware is mostly dead or all dead, depending on how much RAM and processor power you have inside of it. Now, the RAM severely affects your caching capability. The more RAM you put in there, the more cache material it can store inside of the RAM, and the faster response it will have to your clients. The processor really deals with how many packets the ISA server can process at a time. The higher power processor you have, the more packet flow you get. And that also depends on your network card as well. Now, the services and applications running on the server. I know sometimes you just have to have other applications on there. The budget says, you know what, we don't have the money for another web server, so you combine that functionality with the ISA server. The more applications and services that you run on that server, the slower it's going to perform for the ISA. So if it's at all possible, try and distribute the load. Try and make ISA server a dedicated firewall and caching server. And hey, if you could even split that up and have one ISA server as a caching server, the other as a firewall, you will get the most optimized performance possible. Now, you'll never go beyond your physical network limitations as well. I mean, if you have a T1 line as a WAN link and it is 100% utilized or 80% utilized most of the day, you need to upgrade the WAN link. There's no quality of service that can really save you. I heard somebody put it once that it's like rearranging the deck chairs on the Titanic. You're still sinking. Your WAN link is still overwhelmed. It's just the order that you're putting packets in as they're getting dropped. So overall, if you need to upgrade the physical network limitations, sometimes that may be a necessity. Finally, the network protocols and the services that you run on that network have a big impact on the performance. For example, IPsec has the ability of encrypting traffic at nearly every layer of the OSI model. However, the more encryption and the heavier encryption that you apply, the more overhead it's going to take. So sometimes you will need to sacrifice encryption and security for the sake of performance. All of these fit into the context for what performance measurements you can make. Now we can start talking about how to optimize your network. One of the keys to successful optimization of an ISA server network is to establish a very accurate baseline. Now, what a baseline is pretty much data gathered over intervals and averaged out to give you a style of chart like you see on the screen. Now, this is just a baseline of a single day from 12 a.m. to 11:59 p.m. of the daily network traffic. To establish a reliable baseline, you need to monitor it for days and weeks and months, perhaps even years if you have that sort of data available, and it will let you see what normal levels of traffic are. Using that, you can perform trend analysis, which is really just a fancy term of saying this is the normal, something is out of the norm. To figure out what is out of the norm, you need to define threshold values. A threshold value is where you draw the line in the sand and say, okay, this is going a little too far beyond the norm. For example, maybe I said that right here is the norm for database traffic. All of this stuff happening above is above the norm. This is a high threshold value. We might have stuff below the norm, and we might say, well, this is a falling threshold value down here. Overall, setting these values and figuring out what your thresholds will be lets you decide when something is out of the norm enough that you need to do something about it. As a matter of fact, let me show you something that's really interesting. I just received this traffic analysis in my email yesterday, actually. It's from a company that would like me to come out and really optimize their network and figure out what on earth is eating up all their bandwidth. Now, I went ahead and blacked out the names to protect the innocent, but overall, they have an ATM interface, and they emailed me this chart saying, well, this is the daily graph, a 5-minute average, and I can see over the course of a day when the traffic peaks are, inbound and outbound based on the green and blue colors. Now, if I scroll down a little bit, I can see that I have the weekly graph using a 30-minute average, and I can find out the peaks, inbound and outbound traffic. And as I scroll down, they have a monthly graph, 2-hour average, and a yearly graph with a 1-day average. Overall, this company wants me to find out what is eating up all this bandwidth, and one of the things I need to do is sit down and analyze what on earth is happening, what is causing these giant peaks of blue. This is outbound traffic. Now overall, I think I'd be giving too much information away if I went any further, but this is the style of network where I would expect some users to use applications that could gobble up this amount of internet bandwidth. So my next step was going to be looking at what applications are in use on the network, grabbing a packet sniffer, and analyzing at certain times of the day what sort of traffic trends I'm finding. So let's look at one of the tools that is the most common for gathering data that can be used to optimize the network, the performance monitor. Now, hang on. I know some of you might be thinking, that's it. I'm fast forwarding through this section. I've seen performance monitor. Well, I'm sure you've seen it. Most people have. However, in my experience, there's a lot of technicians that have seen it. They think, wow, this is great to see some great, live charts and watch the processor utilization go up and down. But overall, I found a real lack of experience of how to actually gather useful data and log it and say, this is a trend. This is what's going on inside of my network. So let's start off with the foundations of Performance Monitor, and then I'll spin it towards the Isoserver. The first things first, you have the ability with the Performance Monitor to come in here and have the 3 different views. So let me go ahead and add a counter. I'll hit the plus sign and just go ahead and add the processor utilization. That'll give us some actual movement in the spike. In this view, we're able to see the graph. And this is great if you're watching real time what is going on in the network. However, if you want to see a histogram, kind of a little pie chart or a bar chart of what's happening with the processor utilization, or as you add more counters, it'll become a true bar chart, since right now it's just one giant bar, you can see the actual statistics down below. Now the final view is actually my favorite. It is the report view. And this one allows you to see facts and figures on the screen, and just takes a sec to come up, of what it actually is, in this case, in decimal notation for the percent processor time that is happening right now. Now, watching the facts and figures in real time can be handy, but it's only really useful when you're trying to find something at that exact moment. When you're saying, you know what, at this time of day, I notice a spike and I want to verify it, let me go ahead and pull out the real-time counters. What you will use 90% of the time when you're doing trend analysis is going to be the performance logs and alerts. What these are pretty much log files that the performance monitor can track over an interval of time, record, and then report to you in whatever format you find fit. For example, the counter logs come with a sample one. I've got the system overview, which I activated. That's why it's green. I'll go ahead and deactivate this right now. It's been recording activity in the background. Now, Performance Monitor comes with this counter, and this is what a lot of people use for the base monitoring. Look at the properties. It's looking at 3 major counters: the memory, pages per second. That's how many times the memory has to refer to the page files. The physical disk, the average disk queue length, that means how many times data has to be queued up to be written to the disk. And then the processor and the percent total processor time, which is what we were just looking at. Using these three counters, you can find the major hang-ups on most servers: the memory, the physical disk, or the hard drive, and the processor time. This is why Microsoft has created this default log file, and by default it'll take every 15 seconds it will sample the data over an interval of time. 15 seconds is good if you're monitoring maybe over an hour or about a maximum of a day. Okay, once you go beyond that, your log file is going to grow too big. And for that, they have the minutes, hours, and days that you can change it to. Now, you can't modify this default log file. If I click OK, you said modifications aren't allowed for the default logs, because Microsoft has really generated that one for you. You need to create your own by right-clicking on, in this case, we'll start off with counter logs, hit New Log Settings, and we might say ISA Monitor. And we will add all of the counters that we find fit. I'll go ahead and add just a processor for now, that we find fit to monitor the ISA server, and then what interval we would like to monitor it over. From there, we have to set where our log file will go, what the file name will be, and what the extension on the file name will be. Now, by default, it will just be a number that increments as the log file size reaches its maximum limit, or we can go ahead and limit it to a certain number of size. This allows you to generate multiple log files over a series of time, an interval of time, I should say. The schedule up here allows you to set what schedule you would like this log file to run at. Do you want it to run manually? Do you want it to run at certain times and dates? Do you want to stop the log at a certain time and date when the log file is full? How do you want to do this? And it says when the log file closes, do you want to run the command or start a new log file? What is the story with how you want to schedule it? Now, with this in mind, let me go ahead and just cancel out of this one for now. Let me show you how to view a log file that's been recording. I'm going to go back to the system monitor, and I'm going to go to the properties. Now, this is kind of tricky, believe it or not. I'm going to right-click on this and hit properties and show you that there is nothing there. I will go to the action menu and hit properties and show you there's nothing there. To get to the properties of the system monitor, you have to use the toolbar shortcut. I don't know if it's a bug or if it's meant to be that way, but it really has always been that way. And right here, we're at the system monitor properties. Instead of viewing the real-time data, and by the way, this shows you what view you would like to see, but instead of viewing it through the current activity on the source, you want to select a log file. And in this case, I'll open that system overview that I've been recording for a little while, which is the default Microsoft log. I'll hit open, and it lets us set a time range if we'd like. This will allow you to focus your data on exactly what you want to see. Now, the time range I have from 9:30 to 9:41 isn't exactly that long, but if it were, I could go ahead and slide these bars on over and say, well, I just want to focus in on just this data range because I know that's when the problem occurred, or that's when my peak performance is, or that's when my network gets overloaded. Now, by default, I look at the data, and it's only displaying the counter of processor time. Now, I know that the counter log, the one that I was looking at, the default Microsoft one, recorded more than that. And what we see here is that only the counters that it recorded are available to me. So I can go ahead and add those specific counters if I want to see more from that data. So the counters it records, I can filter exactly what counters I want to see. From here, I also have the graph and how large the graph will be. And this is a big deal right here, the vertical scale. Right now, I have it set to a maximum of 10 counts. And I can adjust that to be whatever I want. Once you look at the graph, you'll be able to adjust it so that you can focus in on exactly what digits you want. The colors are adjustable, the fonts are adjustable, but I'll go ahead and click on OK so we can see this graph. Now, what I instantly see is that I'm not using any of the data between around 20 and 50. So I want to adjust my counters to make sure I look at the data exactly as it is. Now again, the graph doesn't go too far because I didn't have that much data recorded. It was only 11 minutes. But this allows me to see the log data for that. Now this right here is your trend analysis. That's why I get so excited about this, is because right here I can say, oh, well, what's going on here? I had a spike in my pages per second, so my memory utilization was peaked out at this point. Right here I had some processor utilization. Now, of course, in the real world, in a real recording, you would actually see it much like the graph that I showed you that somebody emailed to me. It would look much more full and have much more data inside of there. Now, let's change the focus from processor and memory and disk space to actual ISA server data. We're looking at the performance monitor right now, but you know what? ISA server includes a performance monitor of its own. I'm going to click on Start, Programs, Microsoft ISA Server, and show you it has ISA Server Performance Monitor. Now, it's not a different application. It's the same application with all the common counters for ISA Server added to the list. One of the great things about Performance Monitor is anytime you don't know what one of these counters are, you can always find out what it means. For instance, let's say the active sessions. I don't know what that is. I can go to the Add Remove Counters area, go to the performance object that it's under, and active sessions is under the ISA Firewall Service. Click on the counter that I want to know about and hit Explain. It will tell me what that counter is, and I can click on any one of those counters and find a good explanation of each. Now, of course, you might say, well, how did you know it was under the firewall service? Well, I know that just by working with these so often, but I'll tell you what, for all these counters, nothing beats a great reference book. There's many good books on ISA Server out there. They all list all of the counters and what they are. It's a great way to find out what each one of these counters are in this area, because these are the most common counters that you'll run into. Now, when we get into the logging and some of the counter logs, we can create counter logs to find out the historical data for ISA Server. But what about some of these other logs, like the trace logs or the alerts? Well, trace logs have a feature that is pretty handy. Instead of being triggered by time, where you set a certain time range or a certain log file size in the counter log, they are triggered by an event. So after a certain event occurs, the trace logs will kick on and start recording data. But by far, one of the most popular, handiest, critical features of the performance monitor is the alerts. This allows you to alert an administrator when you reach that high threshold or low threshold that you're monitoring for. Now, there are no alerts by default, so I'll go ahead and create a new one. Let's say that this is for ISA Server Cache Space. Now, from here, it lets me add a comment so I know what this is for, but I think that name is descriptive enough. Then I can come in and add my counters. Let's say I want to alert the administrator. Let me scroll up here to the ISA Server Cache. I want to alert the administrator when the total disk failures, I'll click on Add, and by the way, the total disk failures is the number of times ISA Server failed to read or write from a disk due to an input-output failure since the web proxy service started. Now, that's a pretty serious error. So I want to alert the administrator when the value is over 0. Okay, meaning that as soon as I have a disk failure, it can't read or write from the disk, I want to alert the administrator. From here, I get to say, what do I want to do? Do I want to log an entry in the application event viewer? Do I want to send a network message to a specific username or a specific computer? Now, in order to make this one work, you have to make sure the messenger service is enabled on your computer. And let me show that to you. The reason I spend the time on this one is because many people have disabled it because of that cursed internet spamming that's been going on. This is the messenger service. It has to be started. Many of you know what I'm talking about when I say internet spamming. There's corporations out there that have the application that can spam your messenger service and have all these pop-ups end up displaying on your computer. So some people stop that. If you stop the messenger service, you won't be able to use this feature and have a message go bloop wherever you're logged into. That's a really handy one. You can start a performance data log, and you can set a certain log under the counter logs that you want to start recording when this event occurs. You can run a specific program, have command line arguments, and they're showing an example down here, in case maybe you want to shut down the system or you have some external program that does log files. Finally, you can adjust the schedule. When do you want to start watching for this error? Do you want to start watching manually, enable it using the shortcut in the alerts area? Do you want to start now? This is the actual current date and time. Do you want to stop it manually? Do you want to stop it after X amount of days or at a certain date and time? So overall, you can schedule these alerts to happen whenever you want. And the power is you can enable as many alerts as you want and have administrative notification happen anytime a significant event occurs on your ISA server. Before we go any further, let's do a quick progress check as to where we've been. We've talked about the general optimization rules and techniques and some of the context that you have to put things in when you're looking at the ISA server optimization. And we just finished up with a performance monitor, looking at some of the tips and tricks to make it alert you when something happens and all the ISA server add-ons that have plugged into it to allow it to monitor some of the ISA server direct characteristics. Now let's take a trip into the registry performance settings and the nitty-gritty behind the tweaking of ISA server. All right, here we go into the ISA server registry modifications. I went ahead and jotted them on the screen, so if you are writing things down, you'll have something to refer to. The first things first, all of these registry modifications are located in the HKey local machine, system, current control set, services, and then these are all the extensions that come after that. That's the ... And I'll go through them one at a time. First off, the ones in red. The reason they're in red is because they're already existing in the registry. You just change what the default is. These other ones in black are keys you actually need to add to the registry. They don't exist right now, and you have to add them one at a time to tweak the ISA server settings. So first off, the W3 proxy parameters outstand accept. What the outstand accept is the number of accepted pending connections before new connection requests are rejected. By default, this is set to 500, which means that it can have 500 pending sessions waiting for those sessions to establish before it will start rejecting new ones. The higher you set this, the more active sessions it can actually accept all at the same time, but the more memory utilization it requires. Now, also the higher you set that, the more open to attacks you are. As I mentioned, the default is 500, which means somebody could, hacking attack-wise, try and establish 500 half-built sessions. This is a known hacker attack that tie up your resources on your ISA server. Now, the max user port. The max user port is the number of TCP/IP ports that can be allowed by a client making a connection request. By default, this is set to 65,535. So that pretty much says a client making a request could use up to 65,535 ports. That's all the ports that are out there. So if you want to tune that down a little bit, it keeps one user from eating up all the ports and eating up a lot of resources. This can also be used as a general hacking attack. Now for the ones that you have to create if you want them to be used. And they do get pretty nitty-gritty, so bear with me on some of these. W3 proxy parameters, TZ persist interval threshold. What this is how long ISA server can sort out the cache in minutes if the W3 proxy service stops unexpectedly. So maybe you have some sort of failure. The W3 proxy service shuts down. Well, at that point, the cache is unreachable. Once it starts up again, it's going to have to go through all of the cache, sort it all out, figure out what's in there, and you can set how long maximum the ISA server can take doing that. Now, the lower you set this number, the faster the cache will be available. However, the lower you set this number, the more inaccurate the cache will be. As in, let's say we set it to 1 minute. That means the ISA server has 1 minute to sort out everything that's in the cache, could be gigabytes in size, sort it all out, figure it out, put it in alphabetical order, and then use CARP to distribute it on all the servers if that's how you have it set up. If it can't do it in 1 minute, it'll pretty much cut the line there and say, okay, you know what? I've tried. I've put my minute's effort. Anything that I don't know where it's at, I'm going to retrieve straight from the internet. So this can be a dangerous parameter. This one's closely related, the recovery MRU size threshold. This defines what should be sorted out first in terms of minutes. Here's the idea. The ISA server, when the W3 proxy service starts up and looks at the cache, is going to see all this stuff in there, all this files that have been stored in the cache data. This tells it what it should sort first. By typing in a 5 in this parameter, it says sort the things that have been saved within the last 5 minutes before the service failed first. That pretty much says recover the most recent items from the cache first, then go ahead and fail over to all the older items. Now the last two. Max client session. This one is a key that you can use to control the size of the pool for the client sessions. Overall, ISO Server can only support so many client sessions, and it keeps all of those sessions active as long as it possibly can. That is, the maximum client sessions. The reason we have this parameter and we can set it is because it eats up resources to shut down and free up those sessions. By setting the max client session to a low number, it means that overall, your sessions won't last very long. They will be replaced by new ones, and the resource utilization will be higher because it's constantly shutting down and freeing up sessions. By setting this to a high number, you allow the ISO server to maintain sessions for a longer time, but also you eat up memory utilization and processor resources because it's maintaining many sessions all at the same time and keeping them active. So it's kind of a give and take. It's one of those big scales that you have to weigh out what those are. And like I said, this is getting really nitty-gritty down here, which is why these are keys that you have to add. The final one, the TCP timed wait delay. This is closely related to the max client session right above it. And the TCP timed wait delay is a value that sets the time interval in seconds that will pass before a socket is reused for a new connection. So overall, you're going to have your sockets going through your computer, each one being an individual application attempting to access a remote resource. And this pretty much says how long before that socket times out and is reused for some other application trying to get through and establish its own socket. That time, again, is in seconds. I warned you, it gets in some pretty wild stuff when you get into that registry, and it really does let you tune just about anything. And that was just the primary keys available. There are many other registry keys that you can access if you just open up Registry Edit or regedit and start looking down through there. Most of them are fairly logical, and you'll be able to figure out what they do. Now for the final section. Let's talk about Windows 2003 integration. When you're going through and setting up a Windows 2003 installation, you will see some error messages. Here's the process. The first step is to install ISO Server. And matter of fact, let me show you some of the messages you'll see right now. I'm going to go ahead and start the ISO Server auto run, which brings up our installation screen, and just hit the Install ISO Server. It pops up and says, ISO requires Service Pack 1 to function correctly, but it doesn't give us all the information. I'm going to go ahead and go through this, and I'm going to pause the recording while this happens. You've seen the installation enough. And at the end, you're going to see some things pop up that may frighten you. So let me pause the recording, go through the install, and show you what happens. Okay, I finished the installation wizard, and here's the message. Yikes! Devices or applications disabled. ISO 2000 will cause Windows to become unstable. Windows has prevented these drivers from loading. Click here for more details. Overall, ISO Server will not work on Windows 2000. You'll also get a setup has failed to start one or more services menu as well, or message as well. It will not work with Windows 2000 until you do the second step, which is to install ISO Server Service Pack 1. This little service pack will run through, just copy some files, and then tell you to reboot. Once you reboot, ISO Server will be okay. However, do not be dismayed because there is still more to it. You still need to install this ISA-HF255.exe. What is it? It's a hotfix. Overall, Service Pack 1 will let ISO Server function on Windows 2000. Nothing will fail. It will seem to work correctly until some time passes. Give it a couple seconds. Overall, some weird things will end up occurring. There's actually a whole article on Microsoft's website. That is what makes it so critical for you to install this exe file, the ISA-HF255, because it seems to work okay. Even enough so to trick you into putting it into production if you think everything is okay. Overall, like I said, there's an entire article, knowledge base article 331062, that describes all the fixes that this thing applies. The hotfix patches the rest of the holes to ensure that it works seamlessly with Windows 2000. Finally, you need to install ISO Server Feature Pack 1. While it's not required to work with Windows 2003, this does fix a lot of bugs, and it adds a lot of neat new wizards and features to ISO Server. Microsoft, again, has an entire write-up as to what Feature Pack 1 does for ISO Server. And I even heard a rumor way back when that all the new service packs were going to be called feature packs. I'm not sure if there's any truth to that because feature pack 1 is the only feature pack that has emerged for IsoServer. In this nugget, we have seen how to make IsoServer work in the most optimized way possible. It's going to take some work on your part because it does require some general optimization rules and techniques, some of the context that you put it in when you think about increasing the performance of IsoServer, as in what sort of hardware are you working with? What is your network limitations? I showed you also how to go through Performance Monitor to find out and track a lot of the trends that happens on your network, and that allows you to perform trend analysis so you can set some high thresholds and low thresholds of what you can expect from IsoServer. We finally got into tuning the ISO registry settings for the down and dirty configurations and how to make IsoServer work with Windows 2003. I hope this has been informative for you, and I'd like to thank you for viewing.